Welcome dear friends. In this video, I would like to discuss second law of thermodynamics. Before we discuss second law of thermodynamics, it is necessary to understand need of second law of thermodynamics or some limitations of first law of thermodynamics. The first law of thermodynamics does not tell us why a spontaneous reaction proceeds in one direction and not in the opposite direction. Second, the first law of thermodynamics does not provide the information about the practical probability of any process. Third, the first law is unable to put any restriction on the source of heat and its direction of flow. Next, it does not give the information about the spontaneity, direction, and extent of chemical changes. And last, it unable to state the condition under which the absorbed heat energy will be converted into work. We know the first law of thermodynamics states that energy can neither be created nor be destroyed, but one form of energy is converted into another form. But there are some limitations for this statement. For example, if we apply brake to stop the rotating wheel, then brake system become hot due to friction. Internal energy of brake system increases. When brake system loses its energy, wheel cannot rotate with its initial velocity. Though it is according to the first law of thermodynamics, it will never happen. And first law does not explain why this is not occurring. That means first law unable to state the conditions under which heat energy will be converted into work, or first law unable to put any restriction on the source of heat and its direction of flow, or it does not explain the practical probability of any process. So all these inabilities forms basis of second law of thermodynamics. Now we discuss the statements of second law of thermodynamics. To overcome the inabilities of first law of thermodynamics, the scientists Clausius and Kelvin put forward the second law of thermodynamics, which can be stated in different ways. First, heat cannot pass of its own accord from a cold body to hot body. We all know heat passes of its own accord from hot body to cold body. But the statement of second law of thermodynamics state that heat cannot pass of its own accord from a colder to hotter body. That means there is the restriction of direction of flow of heat. Now second statement, all naturally occurring processes tends to proceed in a direction in which equilibrium will take place. All naturally occurring processes tends to proceed in a direction in which equilibrium will take place. Third statement, all spontaneous processes are irreversible. Here, every natural process or every spontaneous process will proceed in one direction and not in the opposite direction. Every natural or spontaneous process leads to dissipation of energy. Means in case of any natural or spontaneous process, some energy will be dissipated. Means some energy will be lost. That is, energy cannot be completely converted into work. Next statement, it is impossible for a self-acting machine to convey heat from a body at low temperature to the body at higher temperature without aid of any external agency. Means without help of any external agency, heat cannot be conveyed from a body at low temperature to the body at higher temperature. Next statement, it is impossible to construct a machine which will convert heat into an equivalent amount of mechanical work without aid of external agency and without producing changes elsewhere. That means it is not possible to construct machine which will convert complete heat into work. As per the first law of thermodynamics, we know one form of energy is converted into another form. But second law of thermodynamics states that it is not possible to construct a machine which will convert heat into an equivalent amount of mechanical work without help of any external agency, without producing changes elsewhere. That means no machine has 100% or unit efficiency. No machine has 100% or unit efficiency. Next statement, entropy of inverse is increasing while free energy decreasing, but the total energy of inverse is always constant. That means entropy of inverse tends towards maximum. Thank you.